Let me increase it. Is this better? Thank you, thank you. All right. Take this. Bear with me. So, all right, let's get started since we're already behind schedule. So thank you all for being here. My name is Raymond de Jong. I work for the company called Isovalent. My role is a field CTO, so I do a lot of workshops and sessions like this to talk about Cilium and Tetragon and how it can provide value for your networking and Kubernetes clusters. Today I'm going to talk about enhancing network and runtime security with Cilium and Tetragon. My talk will be focusing on Cilium and Hubble, so the networking piece, after which we have also a workshop today scheduled with Stefan, my colleague, who will also be able to show in a workshop, in a lab format, how Tetragon actually works, so you can try it out yourselves. You already saw a demo in the previous talk as well, so it's awesome technology to check out. Agenda, I want to talk about Cilium and eBPF. How many of you know about Cilium? A few hands. And how many of you know about eBPF? Same, okay. So for those who doesn't know, I will introduce the technology, how it works, after which I will dive into security, including multi-cluster security, and our observability platform, which enables you to monitor the traffic in your clusters and to make informed decisions about how to secure them. And if we have enough time, I also have a little demo to show how you should possibly get this done, onboarding an application using Hubble and Cilium. So first of all, let's start with Cilium and eBPF. Both are open source projects. Cilium is created by some of the co-creators at Isovalent. So Isovalent originated Cilium. A number of engineers and our CTO created Cilium and donated it to open source. We also have seats in the eBPF Foundation, so we have provide input in where the technology is evolving to and what's coming for future with eBPF. So what is eBPF? We like to say what JavaScript is to your browser, eBPF is to the kernel. What we mean by that is that we make the kernel extensible in a very programmable way without actually changing the kernel. And that's very powerful because it allows us to run in kernel space small programs which are sandboxed and isolated for specific purposes. And for today, we focus mostly on the networking related functions. So think about something sending a packet on the wire, a network device sending a packet. Those are events in the kernel where we can attach eBPF programs to. So for example, for observability, when a pod sends something to another pod, that's a kernel event we can inspect, and we can get metrics, and we can get observability in terms what services are talking to what other services, what protocols they use, what kind of latency they have, and so forth. Cilium is built on this technology to provide networking, observability, and security solutions, not only for Kubernetes clusters, but also standalone high-performance load balancing, for example, or extending your Kubernetes capabilities also to external workloads. For example, a data warehouse running on a Linux box with a lot of data which needs to be secured. You can also extend Cilium there. This is a high-level the 30,000 feet picture of where we are today in terms of features. We have a lot of features with Cilium. We introduced, for example, Service Mesh. We introduced Cilium Tetragon. We introduce for each release new networking features, including SRv6 and others. But today we'll focus on mostly the network policy side, so the security side, including the visibility there, and the Cilium Hubble piece where we provide these metrics, service maps, logging capabilities, and exporting metrics to Grafana to give meaningful dashboards on your workloads. Interesting to know is that we're extending partnerships with clouds. So, for example, Microsoft is one of our recent partnerships where AKS clusters by Microsoft are going to be run Cilium by default. And that's for a good reason, because they identify that Cilium provides the right performance and scalability features for high-scale clusters. And with high-scale clusters, I mean anything beyond 40 to 50 nodes. You need to have Cilium in place, because otherwise you will run into issues with updating IP tables in traditional IP tables-based CNIs. And we provide a Q-proxy replacement for such solutions, and Microsoft, for example, moves and adapts Cilium per default for their AKS clusters. Google Data Plane v2 under the hood is Cilium. EKS Anywhere for AWS is also Cilium by default. And you can also obviously install Cilium on cloud, on OpenShift, on-prem, or on bare metal. So let's dive into the security part. So what's different with Cilium is that we are not interested in IPs, but instead in identities. Obviously, running Kubernetes workloads, this means that you are tracking a lot of pods, tracking a lot of flows, and tracking IPs, especially in cloud, doesn't work. What Cilium does is we create, based on each unique set of labels, a unique identity. So in this simple example, I have a front end and a back end service, each with a unique label, the front end and back end. Each have a unique identity, and this is a cluster-wide identity. And we use this identity to attach it to the data plane when, for example, a pod sends a packet, and also inspect that identity when the receiving end gets traffic from that pod. So if you create a network policy, for example, we use this identity to verify if this traffic is allowed as such. And we also use this identity to observe traffic and to get metrics of those identities. So you're looking at service-to-service communication instead to IP communication. This identity is also being used in multi-cluster security and observability. So across clusters, we can also track identities. Furthermore, we provide layer 7 API-aware authorization. So beyond the primary layer 3, layer 4 network policies, using Cilium network policies, you can also allow specifically on layer 7 specific API calls. So you can, for example, inspect HTTP requests, and we can secure that only, for example, a GET method on the /public URL is being allowed and nothing else. So how does that look like? This is a simple example from a Cilium network policy, is where front end is allowed to talk on port 80, but also method get /public on a specific endpoint. So this allows you to get layer 7 specific API security. Besides HTTP, we also support layer 7 protocols like gRPC, Cassandra, some others as well, which I've got. So a set of layer 7 protocols for securing that connectivity. So in this example, it's a Cassandra example where we select or only allow a specific query action on a specific table. So again, allowing you to have super secure communication between services. Besides that, also matching capabilities. So you want to be flexible in drafting and creating network policies. And we do so by using, for example, pod labels, namespace labels, which in themselves have an identity as well, or service account names or cluster names in a cluster mesh kind of configuration. And also being able to do filtering on FQDN. So we also allow creation of specific domains you can reach, which I will show in the demo. But also obviously CIDR blocks with exceptions. You can also do deny rules if you want. And with cloud provider integration, we can also understand, for example, VPC, subnet, and tags IDs, which you can also use as a source or destination in Cilium network policies. And logical entities, so we provide things like world, remote node, local node, and others for constructs to allow or deny in specific policies. Starting with network policies can be challenging, right? You need to know how the CUD works. You need to know what's coming in and out, and we provide a tool for that to support you. So I really recommend the network policy editor we created. It's reachable through editor.cilium.io. This gives you a graphical interface of how you can create a flow. So you would, for example, click on the central box, which represents the workloads in your namespace, and then on the left you allow things ingress, and on the right you allow things egress. And below you will see it creates this Cilium network policy, which you can download and import in your cluster as such, and that will work and be supported. Also note we support Kubernetes network policy, so if you don't want to use Cilium network policies for some reason, you can still use Kubernetes network policies as well. It also has an included tutorial, so it guides you step by step how you should create Cilium network policies, so I really recommend to try that out. Finally, you can also upload flows, so you can export flows using Hubble CLI and import them using this UI, and you also get recommended network policy. Well, I'll show a bit of network policies as well in action in the demo. So if you want to run multiple clusters, we also have a Cilium cluster mesh solution. And provided you have layer-free connectivity between your clusters, doesn't matter if it's on-prem or in cloud or different clouds, only requirement is obviously layer-free connectivity through VPN or a specific gateway of solution. What you can then do is mesh the clusters together, so 2 or more clusters, up to 256 clusters, together, and you get this unified Cilium data plane. And what that means is that you can use all the features with Cilium, such as service mesh, the network policies, the observability, encryption, across clusters. And that means that you can secure and workloads across clusters and also make them available across clusters. How that works is that each cluster has its own pool of identities, which I just discussed. And each cluster has a read-only entry point in other clusters, and it learns about the identities in those clusters. And based on the network policies you create, it knows which identities are associated with the source and destination to allow or deny traffic, for example. It also means that it's non-destructive, right? So if one cluster fails, it won't ever, never ever impact another cluster, since it's a read-only entry point. Finally, you can also use cluster mesh to extend these capabilities to external workloads. So you can have multiple clusters meshed together to have this single Cilium data plane, but you can also extend this to an external VM. So installing Cilium on a VM, and that external VM will also be an identity which you also can use in your network policies to secure them. So maybe you want to secure access to a database using a Cilium network policy, applying it on your cluster, and the destination will be the actual VM. So what this allows you, the most common use case for cluster mesh is obviously creating high available services across clusters, creating connectivity across clusters, but you can also, on top of that, create Cilium network policies allowing or denying specific traffic from a specific cluster. Maybe you have a zoning requirements or production test requirements, which allows you to, for example, from production not to allow tests to reach you, right? So that can be an example there. And the cluster IDs or the cluster names will be an identity you can use. And this is a simple Star Wars-based example where we want to allow an X-Wing in cluster 1 to contact Rebel base in cluster 2. So we match it on the Rebel base in cluster 2, and then from endpoints X-Wing in cluster 1, we allow port 80 on protocol TCP. Simple example, but this shows that you can use the cluster identity in Cilium network policies very simply to allow traffic across clusters. If we talk about observability, we again use this identity to keep track of flows, what's going on within your cluster and across clusters. And we do that using Hubble. So Cilium Hubble is a solution to provide observability through eBPF on all your flows and identities across clusters. There are 3 main parts. The first part is a Hubble UI component, which shows you a service map. So on a namespace level, you get a view of communication within your namespace, but if something is between namespaces, you will also get that visibility. If something is connecting egress and ingress, You will also see that using the service map. I will demo this as well. For power users, we have a CLI, so you can have specific filtering on specific labels, on specific endpoints. You can also do JSON output, for example, to get flows you want to import in the editor, or to export flows to other platforms like Seam or Splunk-based platforms to do further analysis of data. And finally, obviously, the metrics part. So Grafana and Prometheus is most commonly used to get useful metrics and data on performance of your cluster. And this can be performance of Cilium in general, but also in application performance. So we can provide out of the box, without sidecars, layer 7 metrics. So we can see return codes, we can see HTTP duration and such, and provide you with dashboards of the performance of your application. So this is a view of the service map. So this is a namespace view in this example, a tenant jobs namespace. And you can see all the services within that namespace talking to other services. And you see what is connecting with what. Also, what protocol and ports being used, which identities are associated with it. And in terms of layer 7, we can also inspect HTTP traffic and see what kind of method and URL is being accessed. You can click on specific components to dive in and to zoom in on specific services, and you can use the flow display below to follow all the live traffic there. This is the CLI. I won't spend much here, but again, the same constructs, using identities, labels to filter specific flows. Maybe you want to troubleshoot a specific endpoint, see what's going in and going out. And using the CLI, this provides you all the capabilities there. And Hubble metrics, this is an example of Hubble metrics where we provide layer 7 visibility, also policy visibility, what's allowed, what's denied, how many packets are dropped, etc. More on this later. So one big challenge, obviously, is when you want to secure workloads is that you're onboarding applications where you most likely don't know what's going on, right? You're onboarding applications, you don't know what the requirements are in terms of traffic. Most likely application developers doesn't know them themselves, or they do know, but they don't know much about network policies. So where to start? You don't want to block your developers by denying anything, right? So if you drop anything, no one will be happy, no application will be running, but you still want to apply a baseline policy where you can secure and then move on to actually do the fine-grained security policies for your applications. So what we see most commonly is that we use, for example, cluster-wide network policies to provide benchmark policy for your security across clusters. For example, allowing access to kubedns, obviously allowing Prometheus for accessing your endpoints for monitoring, allowing, for example, centralized services on the network, but then on a namespace level have a baseline posture where you allow traffic within a namespace to start with, and then slowly introduce ingress and egress traffic on a per namespace level. And additionally, using CI/CD to automate that and enable, for example, your developer teams to do self-service of network policies to allow traffic there. But what's key here is that you need a tool to obviously understand what's going on to be able to secure them. And that's what we're going to show in this small demo. And this is a small demo where I already deployed an application. I have a namespace with a simple application client server. It's connecting to the outside world, and then we're going to create network policies based on the traffic we identify to enforce this security. All right, so let me start with this. So again, this is something I just shown. So this is my little app. I have a client and a server service. The client is talking to the server, and we also see that the client is communicating to the world. I need to refresh this because, yes, now I see the line. So you can see the arrows depicting the flows and the communication between client and server. So this is allowed within a namespace. And now I want to secure this, right? I want to know what's going on. So First of all, I would like to know what's going out. I want to understand what's going to world in this case. So for that purpose, I prepared a DNS-based network policy. In this case, only thing I'm doing is I want to be getting visibility of what FQDNs are being reached from this client component. So what we basically do, we're just allowing to inspect all DNS requests by using the Cilium network policy. And obviously, we're inspecting all traffic from each service to the kubedns. So I'm going to apply the YAML. So now we immediately see, by applying this network policy, we can identify that it's specifically reaching 2 domains, right? So no need for me to track any public IPs by using such network policies. So I identified that it's reaching out to isovalent.com and cilium.io. In this case, I'm comfortable with that. I keep that traffic to be allowed. And I will use this information to create a fine-grained Cilium network policy for only allowing these FQDNs to be reached. So what could be a next step? Let's focus on the server part first. So the server receives traffic from the client on port 80 TCP. So let's secure the server. So we created a server Cilium network policy, and we're specified to only allow port 80 and apply this policy. There we go. So this won't change anything in terms of flows in Hubble UI. We also have released a policy dashboard, which I wanted to demo as well. What we're looking at up here is that we want to confirm that all the flows are being matched to a specific policy. So this yellow on the left, on the ingress policy verdict, is a warning for me, like we have no matching policy for ingress traffic. And on the egress side, we just introduced a new network policy, meaning that we're matching on the egress side with the Cilium network policy. And that means that we are slowly getting this namespace more secure. So both are very useful and valuable tools. Now on the client side, I want to make sure that I'm only allowed to reach isovalent.com and cilium.io and only allow access to the server, nothing else. So for that reason, I created a client.yaml file. In this case, by using this statement, ingress with the 2 brackets, I deny everything ingress. However, on egress to endpoint server, I allow port 80. And I also need, obviously, to allow access to Kube API server. And in this part, I want to allow access to these specific domains. And Cilium understands which IPs are associated with those domains. But this is very powerful for you to be securing FQDNs, especially if FQDNs change or IPs associated with FQDNs change all the time. For example, S3 buckets are notoriously known to have their IPs changed all the time. So using 2 FQDN rules is very powerful here. So let me apply the clients. Okay, so on this side, this doesn't change again because we still have this names per namespace allow rule in place. But in Grafana, I should see now traffic being matched on egress, right? So I have now matched all egress traffic with Cilium network policies. I only need to, on ingress, I only need to do the egress part there. All right, so what's next? So I have the client, the server, the DNS. So I now should be able to delete the allow rule. And this should remain for my application to be working. And assuming that we see obviously port 80, let's say I want to know more. Let's say we probably know this is HTTP traffic. Let's enable HTTP awareness in my Cilium network policy to see actually what kind of traffic is being used there. So on the server side, I will comment out this part. And this will trigger the layer 7 visibility, in this case HTTP. I don't have any specific rules yet, but using these brackets, I can see all HTTP-related traffic. So let's update the server YAML. Now I should see at some point with new, yeah, I already see them. So here you see that I've identified on the server, I'm identifying get calls on the / URL. So now I have this layer 7 visibility for specific HTTP calls, and I can make an informed decision if this is allowed or not, or if I see put or post, I can definitely enhance the network policy to drop that specific traffic. And now since we dropped the temporary allow rule, I have confirmation using my dashboard that all egress and ingress flows are being matched by a Cilium network policy, and things are filtered as such. You also may notice the verdict rates. You can also see that this redirected part, that's only informing you that in terms of layer 7, we're redirecting this to our Cilium agent, our envoy proxy, embedded envoy proxy, to do that filtering there. So that's just a confirmation that that's working as expected. And you can also see on the match type here that we have layer 7 matches as well. So now we have secured the application. What happens if you introduce a new application? Let's say in another namespace, you may have a change to your application. How to be alerted on that? So let me quickly change the namespace to, oh, actually, I see I need to create the namespace. Yeah. Oh, it already exists. Kubernetes. Another app. All right, so I need to go to another app, apply this application. So now I'm introducing another app in another app namespace. This will check if this is happening. Yeah, I already see now this other app in the other namespace is trying to reach to the server component in my app namespace. You can see on the red dots here, it's being dropped. And I also see the traffic being dropped in the flows in Cilium in the Hubble UI. So assuming here that we want to allow this inter-namespace traffic, I need to change my server Cilium network policy to allow that traffic. But this gives me at least an alert that something is being dropped. Maybe that's confirmation that it shouldn't or should be dropped, but this allows me to make an informed decision on this traffic. On the server YAML, I need to uncomment this part. And considering time, I'm also doing the assumption here that it's HTTP. So I will uncomment the whole part and update the Cilium network policy. So server. All right. Now we shouldn't see any drops anymore. And we can perhaps zoom in on the another app. Yes. Right. So no red traffic flows anymore. Traffic is now flowing. We can also see that the another app identity is allowed to communicate with the my app destination. And also on the dashboard, we get confirmation of this drops, right? So we see that we got this red verdicts, meaning that we're dropping traffic. So we get also the notification there. And we also see that once we updated network policies, that will be removed again. All right, this concludes my demo, and I have a few slides left. So I just want to briefly introduce Tetragon, what Tetragon is different. Considering time, I will skip to this slide. So Tetragon uses eBPF to do runtime, file integrity, security, and observability. So we use the same technology like eBPF we're using Cilium for networking. Instead, we use it for runtime. That means that we can do file integrity security, for example. We can monitor someone trying to access a specific file, or a process being executed. And if we don't allow that using a tracing policy, we can immediately drop it. So we don't have any, it's a synchronous policy. That means that once you apply this tracing policy and something is not conformant with that, we can drop it immediately. And it's basically related to all kinds of system calls, all kinds of network traffic. We also do low-level visibility. Namespace escalation is something we can monitor, but also access to storage, right? So not only file-based access, but also storage objects. And finally, function calls, code execution, all that kind of processes we can monitor and secure using Tetragon. If you want to know more, I recommend to go to the workshop where we have a lab, so you can actually try it out yourself to learn what Tetragon is, what the tracing policy is, how that works, and how you configure it for that to work. My last slide is to also point you to the isovalent.com labs website, where we have a number of labs of different features. With Cilium, if you're interested, for example, in BGP or load balancing, we have dedicated labs there. Or if you want to know more about Cilium Enterprise as well, you can try it out there. For the community, we have Cilium.io website, including a Slack channel where you can get support for if you're an open source user. Our team is there as well, the community is there, and happy to help you with any implementation or questions you may have with Cilium. And obviously the documentation is very good for Cilium at Cilium.io. If you want to know more about eBPF.io, we have a dedicated website as well. It's recently refreshed and updated. We also have some books you can get at our booth about what is eBPF and also specifically about eBPF security and observability, written by Liz from our company and also Natalia from our company. So if you want to get a hard copy, we still have some available at our booth, and happy to answer any questions you may have there as well. So with that, I thank you for having the opportunity to present this, and if you have questions, I'm happy to answer them. Any questions? Oh, cool.
I have a question. I don't know if it's too theoretical, but the question is, can I also inspect gRPC traffic when I have the protobufs and the certificates?
Yes, layer 7 gRPC is supported, yeah.
Okay, cool.
Yeah.
And you mentioned identities, identity aware. Also, is it automatic discovery for identity service, or we have to, label all our clusters and label all our flows?
It's done automatically. So consider the labels you attach to a deployment to a pod.
Yeah.
Like app equals Nginx and tier equals front end. Those two combined is a unique set for an identity to be created. So our operator, our Cilium operator, keeps track of identities in your cluster and creates it automatically for you. And based on these identities, we can secure it and observe it.
Okay, but that means if my pod has multiple flows, they all have one identity.
Yeah, the unique set composition of those labels is a unique identity.
Okay.
So, for example, if one pod has only the app equals Nginx label, and another pod has app equals Nginx and tier equals front end, those will be two unique identities.
Okay.
Because it's a unique set, right? So that means that we're filtering for those specific identities.
Okay.
If that
Thanks.
makes sense. Yeah.
Thanks.
Any other question?
Thank you for the presentation. I have a question regarding the authorization, layer 7.
Yes.
So it is like, is it going to be a service-to-service authentic authorization, or how Cilium will check that, basically?
Yeah, so typically you have services talking to each other, so you never point a pod directly to a pod, right? You just create a service for that as an entry point for multiple pods, right? So in that sense, it's service to service, but we're tracking identities on the pod, right? So the deployments you create with those identities I just answered with him, those will be the endpoints, right? So based on the network policies you create, you're actually pointing to source and destination identities, like front end is allowed to talk to back end, That means under the hood we know what identities are associated with it, and we allow or deny that traffic.
So yeah, basically it will be a service-to-service authorization
Yes.
for that part.
Yes.
Awesome.
Yes.
Thank you.
I mean, if you don't use a service specifically, it will also work, but that's rarely seen in the field, right? That's
Yeah. I just wanted to clarify on that. Like, is it going to for the user perspective authorization, or it is going to be a service perspective authorization? So it's more
Yeah.
related to service only.
yeah. The view is obviously service to service. Yeah. yeah.
Thank you.
Yeah.
Oi, oi, oi.
Thank you for the talk. I'm interested in how it works with the policies that you define with host names or FQDN, how they relate to IP address or how they are tracked. Is it some reverse DNS lookup or is it some other mechanism?
So whenever a pod does a FQDN query, it talks to kubedns. We are able to we intercept that query, and we also intercept the response, so we understand the underlying IP address being resolved, and reprogram the data plane for that traffic to be allowed. Assuming you are doing a 2FQDN rule, right? So the response is also being captured using Cilium, and the data plane programmed to allow that traffic. Does that make sense? Cool.
You were talking about meshing multiple clusters
Yes.
together. Is Cilium only doing the security, the authorization that one service can talk to the service on the other cluster, or also the routing, the actual routing to that cluster?
Also the routing, yeah. So that's a topic on its own, actually. You create global services. So think about a simple service based on cluster IP, type of cluster IP. Using an annotation with global, this will trigger Cilium to advertise endpoints in each cluster to other clusters, meaning you get high availability routing across clusters. But you can even use service mesh across clusters, right? You can even do load balancing across clusters with those simple constructs with a cluster mesh topology. I'm happy to share some examples on our booth to show you specifically, but it's super flexible in terms of what you can use and how you can route across. So even if you have 4 clusters, you can specify, we call it topology-aware routing. You can really specify if it needs to be local, unless local endpoints are failing, and then forward traffic to another cluster. But you can mix and match all kinds of annotations to get the results you need. Other questions?